Another thing we like to enjoy exploring in our lab is feedback. This is a long tradition in cognitive science, as going, I can't even remember how far back, 60 years at least, that you can get really complicated behavior out of really simple agents that are interconnected and can feed back on themselves. We built this, actually my co-author Mike, who is not here, built this as one of his little projects to explore that. Each of these motors is completely independent. They don't talk to each other at all. And all they do is a really simple program. If this motor tries to rotate a quarter of a turn, the motor turns on and rotates a quarter of a turn back. That's it. But because the motors are physically connected, when this motor tries to turn, it actually pushes the next motor. Which, of course, this motor tries to turn back, it pushes the next motor. When you combine this with the idea of embodiment, namely the importance of a physical structure, in this case the fact that they're physically connected, and that we have wheels which provide differential friction, it's stronger in one direction or another, you put all that together and we get walking without telling the robot how to walk. It's what we call an emergent phenomena, an emergent property, because it's not part of the original design, but it happens for free. And this happens all the time in our lab, and it's what we're really fascinated about, and it's what we explore in the book. So let me give you an example so you can see what I mean. The robot that inspired this was called the homeostat, which was built by William Ashby in, I think it was in the 40s. It also had 4 machines that were too complicated to calculate, but he built it, turned it on, and he described its behavior like a fireside dog. It just stirs around, it reaches a comfortable position, you poke it, it stirs again, and then it just comes to a rest. The same thing, the same general idea is the case with the wormiostat. It's on, it's running. There's no feedback though, there's no stimulus to start it to work. You provide that stimulus, remember, a tiny little turn, that'll propagate through the whole system. And that's all it's doing. And as the feedback builds, because of the way the machine is built, we get a walking motion without telling it how to walk. So the real question here for a cognitive scientist is the walking in the robot? Is it in the environment? Is it where? It's nowhere. It's coming out of it for free through the interaction of everything here. Now, remember how I said Ashby's called this device like a fireside dog that stirs around? We have the same sort of behavior here. Namely, if I damp the feedback, if I stop it from building up like this, down boy. I just impede the motion. I'm not turning off the robot. And it won't rest, it won't do anything at all. There's no feedback to go. I just damped it all. But that won't stop it from moving if it wants to. Surprisingly effective for not actually being told how to walk.